Now we are going to see the final type of arc welding process, that is nothing but the tungsten inert gas welding. So this is the final type of an arc welding process. You can able to see the arrangement. This is the only process which uses non-consumable electrode. So in the first video itself we have seen one comparison, no? So there we have compared the variety of welding process along with the process sequence and the equipments. So in that you can able to remind that so this tungsten inert gas welding process will use non-consumable electrode. What is non-consumable electrode means? So in the previous three types of a welding, so the electrode and flux will be melted and it is converted as a weld pool. Whereas in this type of a welding process, the electrode won't be melt, right? So that is used to create a heat energy alone, but it won't melt at all to develop a weld pool. Instead that we will have a separate filler rod in the other hand. So that filler rod will be melt and it will form a melt pool. So this is the typical difference between the other type of arc welding with the tungsten inert gas welding. So this tungsten inert gas welding is also called as gas tungsten arc welding. Okay, because some of them will get confused since this is having a gas welding. So this might be a type of a gas welding process. No, this is a type of a arc welding process. So that in the other hand, they will call this as a gas tungsten arc welding. So what is TIG or tungsten inert gas welding? So arc welding process that uses non-consumable tungsten electrode, right? Since we are using a tungsten electrode, this process is termed as a tungsten inert gas welding. So to this uses the tungsten electrode to produce a welding. So the weld area is protected from the atmospheric contamination by inert shielding gases. So we are going to use the tungsten as an electrode, inert gas for a shielding. So this is called as a TIG welding process and uses an arc welding principle. So the filler metal is normally used in the other hand. You can able to see this is the filler material, right? So the process is same as you have to recall the soldering or brazing type of a material, brazing type of a process, which is also we are going to discuss in the future classes, right? So this is the typical arrangement of your TIG welding process. You can able to see you will have a welding torch and filler rod. The welding torch you will apply the power supply and the shielding gas. Shielding gas is nothing but the inert gases. So what is the process, right? So the welder turns the gas flow, right? He will give the gas flow, that is an inert gas, either it may be argon, helium, right? Such kind of inert gas will be supplied to the weld pool using the TIG torch. This is the TIG torch. Okay, the torch is held over the weld joint just far apart. Since this is an arc welding process, we have to have some distance between the workpiece and the weld torch. That means usually 2 to 4 mm, right? So which is used to develop a weld pool. Then the welder presses the foot pedal and the TIG torches tungsten electrode start an arcing, right? When a welder or a person who is going to weld will apply a force on a foot pedal. Generally in the TIG welding, he will have a foot pedal. When you press the foot pedal, the electrical circuit get closed. That means the tungsten electrode get charged and it will form an arc over the base material. Once the arc is started, the two pieces of metal is melted by creating a puddling of a metal. So when the puddle is established, the welder with the other hand will bring the filler rod. So usually what it will happen means, so generally we will take this tungsten electrode in a close proximity to the base material and it will forms the arcing, right? It will form an arcing. So once the arcing is formed, there will be a huge amount of heat energy is generated. At that time, the welder will bring this filler wire inside to this high heat established arcing area. So that what it will happen means this filler wire will get melted and it will poured inside the welding portion. So the welding joint will be formed. So coming to the TIC power supply, so usually a welding power supply which supplies the current very constantly, since here we are going to use non-consumable electrode, the welding power supply is very important in such cases. High frequency start eliminates the need to physically strike an electric like SMAW process by creating a brief moment of high voltages. So pre-flow and post-flow features confirms the protection of welding by supplying a shielding gas before and after the welding is performed. So frequency setting helps the characteristics of welding arc, and also we can able to use both AC and DC current in the TIC process, and very importantly here also we can get the straight polarity or reverse polarity. In the reverse polarity, so it will create 2/3 of heat onto the metal which is going to be welded. So when we are going to get when you are going to connect the material like this, we can use this process for deep penetration of a welding. When the polarity is reversed, the 2/3 of welding is reversed and it is formed on the electrode surface. Okay, so this is used for shallow type of a welding. So coming to the welding torch, as of your GMAW and MIG process, here we can able to see a typical arrangement of a TIC torch. So this TIC torch only we are going to supply the gas, inert gas, and also we are going to have the tungsten electrode which is non-consumable. So the basic torch types are air cooled ones. We are having a air cooled torch or water cooled torch. Since in the torch only we are going to get a high amount of heat energy. So the torch are mainly made up of a tungsten electrode, and there is some amount of ingredient which is added to the tungsten to have the life. So there are generally three types of tungsten electrode. One is pure tungsten, and another one is zirconia reinforced tungsten, and third is thorium reinforced tungstens. And the electrode types which is used to create arc for the welding, and tungsten properties allows an arc to maintain a temperature up to 11,000 degree Fahrenheit. So electrode diameter generally varies between 1/16 to 1/4 of an inch, and there are two types of electrodes you can able to see from this image. One is pointed tip. So these two things are pointed tip, and this is typically used for ferrous metal welding. And also you can have a rounded or taper ball type of a tips which is generally used for a non-ferrous welding. Here you can able to see, right? So in the torch you will have a two types of a welding electrodes. One is pointed type, so that is generally used for ferrous type of a welding, and another one is a rounded or a tapered ball, that is generally used for a non-ferrous metal type of a welding. And shielding gas, as the name implies, this is an inert gas using process. So the shielding gas is where we are going to use some inert gases. So this shielding gas are necessary to protect the welding area from atmospheric gas which can cause fusion defects, porosity, and weld metal embrittlement. Okay. And also transfers the heat from the tungsten electrode and helps starts to maintain the stable arc. So most of the cases pure argon is used, right? So the inert gas which was used in this type of a welding is pure argon, and also we are using some amount of mixtured type. One is argon hydrogen, argon nitrogen, argon helium, as we have seen in the MAC process now. So like that we are also using some mixture of inert gases, starts from argon hydrogen, argon nitrogen, argon helium, and all. And the argon helium typically used on thicker metal to get deep penetration, right? So usually argon and helium is mixed to weld very thicker kind of a materials, and also to have a deeper penetration into that. So coming to the advantages, so works on almost all type of metal with a higher melting point. So as the name implies, and also as the name as a process, you can able to see both ferrous and non-ferrous materials can be welded using this TIC process, and especially for reactive metals like titanium, zirconium, which and all dissolves oxygen and hydrogen, nitrogen, and become embrittlement. So such kind of reactive materials also can be welded using the TIC process. So accuracy and control is one of the important parameter of this TIC process, and the process provides more precise control of the welding than any other arc welding process. And because the arc heating and filler material is independently controlled, we are having that accuracy and control. So the welding bead looks very good and very good for joining thin base metal because excellent control on heat input is happen in this kind of a process. But they are also having some disadvantages. This is a slower process than consumable electrode process. It should have a best practice. Without a best practice, we should not weld properly using this TIC process, because the welding torch will be in the other hand and the filler rod will be in the other hand. Only the trained person can be weld very good. And more expensive process and expensive welding supplies, because tungsten electrode and all cost very huge and not easily portable. Transfer of molten tungsten from electrode to weld causes contamination. These are some of the disadvantages. Coming to the comparison, so we need to compare with MIG process, because MIG also metal inert gas welding, and this is also tungsten inert gas welding. So what are the similarities between the TIG and MIG process? Means no fluxes are used, either in a TIG or MIG. No fluxes are used. Instead, that we are going to use the shielding glass to protect from the atmospheric condition. So instead of that, both are using the inert gases, either it may be argon, helium, or carbon dioxide, or a mixture of this we are going to use. This is the similarity between the TIG and MIG. But there is a specific differences between the TIG process and the MIG process. In TIG process, arc is stuck between a non-consumable tungsten electrode and workpiece is welded. Whereas in the MIG process, we are going to use the consumable electrode. Okay, so the arc is struck between the consumable electrode and a workpiece to be welded. So here the filler material is added from a handheld filler rod or a wire of the same consumption as the workpiece, whereas the filler rod and electrode will be fed into the wire form from a real continuous on the weld zone. So here the filler rod and the electrode will be a separate one, whereas in the MIG the both are a same one, the filler rod and electrode, since it is a consumable electrode. Coming to the application, most commonly used to weld thin section of stainless steel, steels, non-ferrous materials such as aluminum, copper, nickel alloy, magnesium, titanium. Most of the reactive kind of a material can be welded using this. So combination of dissimilar metals also TIG welded, such as copper evader, copper to stainless steel, nickel to stainless steel, and stainless steel to cast iron can be welded. So all other three process, only the same material can be welded, but this TIG process, using this TIG process we can able to weld two dissimilar materials also. This is one of the important application of the TIG process.